Now we're going to cover a section that I haven't seen textbooks really address, so this is a little bit unique, but it's probably worth looking at. So horizontal stretches and compressions. Given a function f of x, a new function g of x equals f of b of x, where b is a constant, is a horizontal stretch or horizontal compression of the function f of x. If b is greater than 1, for example, as we'll see in the image in the next page, b is greater than 1, like it was f of x equals 2x, f of 2 of x, excuse me, then the graph will be compressed by 1 over b, so it would be half as wide. If b is between 0 and 1, let's say it's 1/2, so it's f of 1/2 of x, then the graph will be stretched by 1 over b, so 1 over 1/2 would be 2, so it would be twice as wide, and you'll see that in the next image. And if b is less than 0, then there will be a combination of a horizontal stretch or compression with a horizontal reflection, and that ties us back to the topic from 2 topics ago when we looked at graphing using reflections. So let's look at the image that they provided us. In the one case, maybe we should try to make this a little bit smaller. No, too late now. Okay, so we have this darker blue is the original, then this kind of a green, blue, teal, whatever you want to call it color. Coefficient's 2x, so it's half as wide as the original. And so I guess notice along here, the original function went through 2, 4. Now it's going through 1, 4, so it's not as wide. And then for the third function, y equals 0.5x, and so 1 over 0.5 is 2. So this is twice as wide. So instead of going through 2, 4, it's going through 4, 4. So it got stretched horizontally. Okay. So how to stretch a horizontal compression, how to sketch, excuse me, a horizontal compression or stretch. Write a formula to represent the function. Set g of x equals f of b of x, where b is greater than 1 for compression or between 0 and 1 for a stretch. So suppose a scientist is comparing a population of fruit flies. So we saw this problem earlier when we did a vertical stretch, but that progresses through its lifespan twice as fast as the original population. In other words, this new population R will progress in 1 hour the same amount as the original population does in 2 hours. And in 2 hours, it will progress as much as the original population in 4 hours. Sketch the graph of this population. So I'm going to just go on the original graph. And so what would have been at 3, I see this as a key point, that'll occur at 1.5 or 1.5. What would have occurred at 6 will now occur at 3. And what would have occurred at 7 will now be at 3.5. So it's going to sweep up, then it's going to go down like this, and then go down like that. So it has a compressed time because everything occurs twice as fast. Okay, for this next part, we're going to do the table. A function f of x is given in the table. Create a table for the function. So we have g of x equals f of 1/2 x. And so I think let's just look at this. So f of 2 is 1, f of 4 is 3, f of 6 is 7, f of 8 is 11. And so if we were to consider it that half of x is 2, 4, 6, and 8. I'm going to make a new row here. Make this g of x here. Then the x would have been 4, 8, 12, and 16. And so what I'm trying to get at is these would be the x values we are after, but then half of that is how it's being interpreted through f. So g of 4 would turn out to be 1, where f of 2 was 1. So this is that pair we're looking at. G of 8 will turn out to be 3, where f of 4 was 3, g of 8 is 3, because g is doing half of the x value. This is half, so it would be a stretch, not a compression. And then for g of 12, we look at f of 6. So f of 6 is 7, so g of 12 is 7. And then, since f of 8 is 11, g of 16 would be 11. There we go. Confusing myself. So these are the ordered pairs. For g, it's going to be 4, 1, 8, 3, 12, 7, and 16, 11. Okay. Hope that is a little clear. Moving on to the last part of this, we want to relate g of x to f of x. So I look at this solid point. I mean, I use this because it's a pretty round point. It's 2, 4. It's nice whole numbers. I look at this other point that looks similar to it. That's at 6, 4. So I look how the x's have changed. And so 6 divided by 2 equals 3. So this is a compression. So I'd say g of x equals f of 3x. And that's the idea behind a stretch and a compression. So that's horizontally compressed by 1/3. Okay, then we have one more section to cover.